Hello, this is Team 1.2. Our project title is Product Analysis for Pharmacy Store. In this presentation, we will introduce the datasets we used for pharmacy information analysis, the model we implement, and how we compare and improve it. At last, we will talk about the chatbot we realized based on the trend model. Now, I will first introduce the first dataset, which is called the pharmacy sale data from 2040 to 2090. This dataset contains totally 300,000 transactional data from 2040 to 2090. Based on the standards of ATC, it classifies drugs in 8 different categories and collects their sales by hour, day, week, and month. So for this dataset, we first visualized its sales trend to have an overall understanding of the drugs, like some of them may show periodicity and the right line drug have the best sale. Then we try to do more comprehensive numerical analysis to know the exact value of those insights. After that, we performed a more specific trend analysis for those drugs, and we discovered their periodicity or stability among weeks or months. For instance, the category of M01AB maintained a stable demand across the 4 years, while the category of R06 seemed to outperform in winter period compared to the summer. Finally, we used ARIMA to forecast the sale for different drugs in the following years.
In order to better verify the rationality of the predicted trend, we also used an LSTM model to predict the average monthly sales of each drug in next year based on the past 6 months. An LSTM is suitable for this task as it can capture complex patterns and long-term dependencies in time series data, making it effective for sales prediction. As we can see in the result picture, the N02BA, N05B, R03 are predicted to have a slightly growth trend in 2020, and N05B and R06 are predicted to have a slightly downward trend in 2020. And M01AB, M01AE, and N02B remain stable at 150, 110, 850 to 900 respectively.
The dataset 2 is the UCI ML drug review dataset, and this dataset includes 7 columns, which are unique ID, drug name, condition, review rating date, and the useful code. It covers different conditions and drugs, mainly during 10 years. And from this dataset, we can get the top 20 conditions and the drug names. The objective is to classify patients' condition based on the reviews they provide. I tried 2 different models. The first one is the bag of words with naive bias. The occurrence of this model is about 96%. The second one is the DF-IDF with passive-aggressive classifier. The occurrence of this one is about 98%, which is higher than the first one. So we use this model, and we can select a drug with the highest score from the corresponding symptoms for recommendation. And this figures is the recommendations for drugs with the highest scores for different conditions.
I'm here to demonstrate data analysis for dataset 3, the MD drug review dataset. It is composed of 0.36 million reviews and 12 columns, and it covers more than 1,800 different conditions and more than 7,000 different drugs. It is a big dataset, and the underlying pattern should be representative. Let's look into the schema of the dataset. The information can be divided into 3 parts: patient information, drug information, and review given by the patient. We assume that there is a connection between these 3 parts. Our objective is to find a connection to give drug recommendation. We use a shallow neural network to predict the satisfaction rate. To get the meaningful results in both training and predicting, we ignore the combination of conditions and drug that occurs less than 10 times to avoid outliers. Then we use embedding layer to map discrete gender, drug, and condition factors, which is easier for the model to process. Predicting MSE is less than the original variance, which indicates the model fits the data. In the end, we use the model to predict every drug satisfaction score based on the patient information and condition, and recommend a drug with top 3 predicted satisfaction score. Then we put the drug recommendation documents into the data store of RAG, providing information for LLM in runtime.
Okay, now I'll introduce two important models we used in our chatbot, Llama 3.2.1b and Retrieval Augmented Generation, or RAG in short. First, Llama 3.2.1b is a lightweight large language model developed by Meta AI. It has around 1 billion parameters, making it much smaller and more efficient compared to larger models. It is designed to run on constrained hardware, like personal computers, mobile devices, and even Raspberry Pi. However, because of its smaller size, it lacks deep knowledge in special fields like the medical and the pharmaceutical industries. Next, let's talk about RAG, Retrieval Augmented Generation. RAG was introduced to improve how models handle knowledge-intensive tasks. Instead of relying on internal parameters, RAG retrieves relevant documents from an external knowledge base during generation. It combines two probabilities, the probability of retrieving a document and the probability of generating an answer based on the document. There are many extensions of RAG like 5D, RepLog, and Atlas, which improves retrieval quality and reasoning abilities. One major advantage of RAG is that it allows models to update their knowledge simply by updating the external document corpus without the need to retrain the model itself.
Well, this part is about our chatbot deployment. Server deployment is too expensive for some pharmacy stores. So we deploy our model finally in a Raspberry Pi 4 with 3 different kind of models, which is Queen 2.5, Llama 3.2, DeepSeek R1 with around 1 billion to 1.5 billion parameters. Then here are the advantages of this local deployment schemes. First, it is cost effective for the reason that it only needs less than 500 Hong Kong dollar to complete this deployment. Next, with local knowledge base, the LLM is able to answer industry-specific questions with confidence. What's more, local deployment can ensure the data security of some self-built knowledge base of the pharmacy stores. And we can run this model without any internet connection. And finally, here is our running demo. We connect to our device through SSH and run our model. We first type in the role of us here as a customer, and then we give the model our question. Then the model will answer the question with the knowledge retrieved from the knowledge base. Here we ask what is the drug recommendation for a 10-year-old boy with depression. And the model gives its answer. And that's all. Thank you.